Okay, welcome back, and now we're going to do an example of using the fundamental theorem of calculus part 2. So they want us to evaluate this definite integral. So what I'm going to do is I'm going to use the fundamental theorem of calculus part 2 to do that. So the first thing is, does an antiderivative, this is a continuous function over the interval from -2 to 2. Does an antiderivative exist? Yes, it does. Okay, so we can find the antiderivative of this thing by what? Using the techniques of integration that we've learned. Okay, so what does this mean? Okay, so it says that this is going to equal, so this is f of t, right? So this is f of t, right? So we need to find f of x, capital F of x, the antiderivative, right? Well, by integrating this term by term, what do we get? We get we find the antiderivative, and it's going to be what? We use the power rule on this one for integrals. So we increase the power by 1 and divide by the new power. So this is going to become t cubed over 3. And then this is just minus the integral of 4, right? The antiderivative of 4 is just 4t. Right? Because we could think of this as 4t to the 0. And so if we integrate this, the antiderivative of this is going to be what? It's going to be increase the power by 1, so that's going to be 1, and divide by the new power, which is 1. So we get 4t. Okay? So now we're not done, but we have to evaluate this, because now that we found the antiderivative, we have to evaluate this by the fundamental theorem of calculus. We have to evaluate this at the limits of integration. Okay? Oh, by the way, hold on. When we integrate this, we're integrating this in the general case. You'll see why. So why do I need to add the constant? Because when I'm integrating this, when I'm finding the antiderivative, I'm finding the general antiderivative. Okay? So it's this. Now what I'm going to do is I'm going to evaluate this at the endpoint. So it's always top minus bottom. So this is going to be equal to what? It's going to be the antiderivative evaluated at the top limit of integration minus the antiderivative evaluated at the bottom limit of integration. So what I'm going to do is I'm going to have 2 cubed over 3 minus 4 times 2 minus -2 cubed over 3 minus 4 times -2. Now, I forgot my c's. Plus c minus plus c. Now, let's keep going. So this is going to be 8/3 minus 8 plus c. Now I'm going to distribute this and simplify. So this is going to be what? Plus, because this is going to be -8/3, so it's going to be plus 8/3. What? This is going to be what? -8, but it's a minus -8, so it's going to be plus. But then I'm going to distribute this negative, this subtraction, so it's going to be minus 8. And then we have a plus c, so that's going to be minus c. Now look at that. Now watch what happens here. The constant falls out. Now I'm going to stop for a moment and just tell you that will always happen. For definite integrals, when you use the fundamental theorem of calculus part 2, the constants will always drop out. So from now on, you don't have to write it. Because as I've shown, no matter what the constant is, it goes away. Because it'll subtract out. Okay, so now I get 8/3 plus 8/3, which is 16/3, minus 8 minus 8, which is 16. Okay, so my final answer is going to be what? This is going to be 48/3. Yeah, so I'm going to change this to 48/3. And so 48 plus, well, this is doing 64/3 then. 64/3. I think that's the right answer. Oh, no. Huh. I added. Sorry. It should be subtract. This is negative 32/3. It's funny. Okay, so remember, watch your signs. Okay, it's that easy. Now what I'm going to do is I'm not going to deal with constants of integration anymore. If it's a definite integral, the constants of integration always go away. Okay? See you next time.